sit coastal mountain faces and submarine slopes that have been structurally reinforced by permafrost for thousands of years. Those slopes are now thawing from the inside. Several of them are positioned directly above underwater terrain steep enough and deep enough to generate, if they fail simultaneously, a wave that dwarfs anything in recorded Pacific history. The mechanism is not theoretical. Lituya Bay, Alaska, July 9th, 1958. A rockslide triggered by an earthquake sends 90 million tons of material into the bay at once. The wave that results reaches 1,720 feet up the opposite mountainside. It is the largest wave ever recorded in modern history. Lituya Bay is enclosed. The energy had nowhere to spread. The Gulf of Alaska is not enclosed. But the slopes above it are larger. The thaw-compromised faces identified in current survey data contain material volumes that dwarf Lituya. The water beneath them is deep enough to translate that displacement into an open ocean wave that does not diminish. It travels. Dr. Robert Calvert at the University of Alaska Fairbanks has spent 11 years modeling submarine landslide scenarios along the Gulf of Alaska margin. His most recent modeling, not yet cleared for public release, projects that a simultaneous failure event involving identified thaw, compromised slopes above specific deep water zones, could generate an initial wave height exceeding 500 feet at the source. His instruments are currently detecting what he describes as progressive slope destabilization across multiple sites. Methane readings inside several coastal collapse zones are spiking, suggesting that ancient organic material sealed inside permafrost for 50,000 years is now decomposing, expanding, and pushing upward through fractured rock. The same process producing tar balls on Florida beaches is producing gas vents along Alaska's coast. The permafrost was not just structural, it was a seal. And the seal is breaking. Newtok, Alaska. Population 312. The village sits on the Ninglick River Delta, on land that has been losing ground to coastal erosion and permafrost thaw for 2 decades. The riverbank retreats 60 feet per year. The ground beneath homes subsides as ice within the soil melts and the volume disappears. Foundations crack. Sewage systems fail. Fuel storage tanks tilt and rupture. The community has been formally designated for relocation by the state of Alaska since 2009. 15 years later, the process is still incomplete. Families are still living on ground that engineers have documented as structurally compromised and actively failing. Newtok is not alone. Shishmaref, Kivalina, Shaktoolik. These are not remote uninhabited outposts. They are communities, schools, churches, elders, children, the same generational roots that Maria Martinez had in Pompano Beach, except with no highway to drive away on. Evacuation from these villages requires aircraft or boats. The federal relocation cost per village is estimated between $100 million and $200 million. There are at minimum 31 Alaskan communities facing imminent habitability threats from permafrost thaw and coastal collapse. The political appetite to fund the full relocation program does not exist. The ground beneath these families does not care about the budget. A landslide-generated tsunami is not the same as a tectonic tsunami. This distinction is critical, and almost nobody outside the scientific community understands it. When a subduction zone ruptures and generates a tectonic wave, seismometers around the Pacific detect the earthquake immediately. Warning systems activate. Coastal sirens sound. There are minutes, sometimes hours, depending on distance. The 2004 Indian Ocean tsunami killed 227,000 people, with almost no warning infrastructure. The 2011 Tohoku tsunami